Hi everyone. This is Riya Sharma from Java Studio. So today we'll be learning about caching. We'll be having a brief overview of what caching is, and then we'll be looking into default Spring Boot caching, how Spring Boot allows us with caching mechanism by providing abstraction APIs, and then finally we'll be looking into Hazelcast, how Hazelcast acts as a cache provider for caching in Spring Boot. And then we'll be looking a little bit into code, how we can integrate Hazelcast and how Spring Boot default caching works. So that'll be about the session.
Yes, Ria, please go ahead with the session.
Okay, sure. Okay, so before moving to the session, we'll just go through NashKnolX etiquettes. So everybody is requested to join the session 5 minutes prior to the start time. Constructive feedback will be appreciated after the session. It'll help us improve. And keeping your devices on silent to avoid any kind of distraction is requested. And kindly avoid any kind of disturbance during the session. Thank you. Let's move on to the agenda of the session. So as I just explained, here is a brief agenda of what we're going to cover today. So we'll be covering caching and a little bit about caching. Then we'll be moving to the Spring Boot default caching to get an idea of how Spring Boot handles caching if we don't provide it any cache provider explicitly, and how the request processing works from the client to the database, and how caching acts as a interface in between. And then we'll see how Hazelcast acts as a cache provider and how we integrate into Spring Boot and how data partitioning works in Hazelcast cluster. And then we'll be moving to the demo. Okay, so before starting, anybody here would like to explain what caching is? We've been using, we must be using in our daily day-to-day projects as well. Anyone?
Yeah. So, holding up data into memory, which are the frequent access data set for our applications performance improvements is caching. Basically, we can implement it with various strategies. Of course, the key value pair is the most, de
Widely
facto
used.
kind of de facto for building up a cache, but definitely there are other mechanisms that are provided out of the box by several libraries, Hazelcast being one of them. So yeah, so there have been other caching mechanisms other caching providers like Redis, and we have Memcache that we've been using for a very long time. So this is something that I've not worked on Hazelcast so far. So that is something that we've got to be checking out now with your session. So that's great. Yeah.
Oh, great. Very rightly said. Again, who's this?
Indrajit. Yeah.
Oh, thank you. Thank you, Indrajit, for the answer. And very rightly said that very frequently accessed data whenever we work on applications and especially large scale applications. So whenever the load is coming from the client end, so we don't always need to overload our database with the same request every time, right? So we got a solution for this, which is known as caching. So for these requests, we store the data in memory. We basically have a copy of that data. So whenever the request comes, we don't always go to the database for the same request. We go to our caching storage. We get the data from there using various strategies, for example, key that we're gonna see ahead in the session also, right? So we fetch the data from the caching storage from our cache and not from the database, and we send the response back to the client or the user, right? So it will save us computing resources by reducing database and backend processing overhead. So when we talk about caching, when we talk about system, when it works, so we have level of systems, right? For example, we have user, DNS, web application till DB. So that's how a system works. So at every level, we're supposed to have caching, right? So, but here we're gonna mainly focus on application level only, right? For example, if we talk about user on user level caching, so we have a session stored for user. Whenever user visits, we have its session stored, so we don't always need to re-download our session from the database. So that's how the efficiency of the application increases. So here, overall in this session, we will be focusing more on the application level caching. Okay, moving ahead. We have few terms when we talk about caching. So I'll just quickly explain these. Uh, uh, Probably most of you must be aware of these as well. So first we have cache miss and then we have cache hit. So whenever a request comes from the application end and from the client end, from the user end, and we get the request on our controller, so we look for the cache first. Do we have the data already present in the cache? If not, then the request goes to the database. We fetch the response from there. The response gets copied to the cache, and then the response goes back to the client or the user, right? So this is known as cache miss, when we don't find our response or the data that we're requesting for in our cache. Second is cache hit. So when the request comes and if we find the data or the response in the cache with the particular key that we have stored it with, so we send the same response to the application. This way, we didn't have to go to our database to find the response, right? So this was a brief about caching, like what caching is and how it superficially works in our application level. Now coming to Spring Boot default caching. So Spring Boot basically provides us with abstraction APIs for caching. We don't have to configure everything on our own. We can make use of various annotations Spring Boot starter cache has provided to us, and rest everything will be handled by our cache manager. So cache manager here is an important thing to understand because it's like a central interface that will be taking care of all the creation, retrieval, and the management of caches that we're going to implement in our application. So Spring Boot interacts with the cache manager to handle cache operations instead of directly dealing with the cache providers. So when we were talking about cache providers, for example, Memcache, Redis, Hazelcast that we're going to learn about today, right? So if we don't provide any of the provider, what Spring Boot does is it uses its default cache provider, which is concurrent hash map cache manager that we'll be reading about in a while, right? So with Spring Boot, we don't have to manually configure everything for caching. We have got APIs, annotations that we can simply use and implement caching, right? So here is a architecture. Request comes to the Spring Boot application. We look in the cache. If we find the result, we return the response. If we don't, we fetch it from the DB and copy it to our cache. And then when the next time the request comes, it'll look in the cache and it'll find the response there. So these are the few annotations that we have that has been provided us by the Spring Boot. We're not going to go too much deep into all these annotations, but I'll be giving you a little brief, but in the code base. But moving forward, I'll be explaining about enable caching because it's an important annotation that will play a major role all throughout. So when we enable our application, it's a class level annotation, okay? So mainly we put it in our main application class. So when we enable our application with this annotation, what happens is that Spring Boot automatically registers all the beans, all the dependencies required to support caching operations in the application context. So when we put this annotation and we have the dependency in our POM, so what happens is all the dependency is stored in the class path. So whenever now you're going to use all the annotations related to caching, the dependencies are already there. We have told Spring Boot that the dependencies are there, use it. Now we're going to tell you which method should be cache and which response should be cache, right? So it's a class level annotation to enable caching in Spring Boot application. And by default, it set up a cache manager and creates in-memory cache using concurrent hash map. Cache manager, as I just explained, that it is going to take care of all the retrieval, all the management of our caches that we're going to implement in our application, right? Sorry. And it creates an in-memory cache as well, which is known as concurrent hash map. So this is the data structure where our data is going to get stored. As Indrajit explained also that we have keys. So hash map stores the data in key value pair, right? So whenever the data comes, we give it a key and that data gets stored in our cache memory with that key. So whenever the next time the request for the same data comes, we'll see that if the key exists in our cache or not. If it exists, we'll send the same response, right? So this annotation enables a caching infrastructure in our boot application. By enabling caching, Spring Boot automatically registers the beans in our class path, and it will process cache annotations like cacheable, cache put, etc. This will be seen more in the code base where we use cacheable and where we use cache put, right? And it also initializes cache managers for the appropriate cache provider. Now, since we've been talking about cache providers, and in Spring Boot default caching, we don't provide it with any of the cache provider, but later we'll be providing it with the Hazelcast. But since now we have not provided it with any of the cache provider, what it does is it uses a default cache manager, which is concurrent map cache manager, which creates in-memory caches backed by a concurrent hash map. And where the data will be stored? Here in concurrent hash map. Any doubt till here for this annotation?
So Riyadh, is this a distributed caching mechanism or a cache set up by Spring, or is it just
It's
setting it up in that node?
Yeah, it's for per instance and per node only. Spring Boot default doesn't provide us with the for multiple instances and for distributed mechanism. That's why we're reading this default mechanism so that we can make a comparison of why different cache providers comes in picture when we deal with large scale applications.
Okay, all right.
Okay. So next up we have it's basically I have put this here to get the practical gist of how the request comes and how cache plays a role in our application. So how the request processing works basically from the user till the database and with the cache in between. Okay. So the client sends a request, we hit an endpoint, for example, and we get the request in a controller. At controller level, it'll look for the method in the service layer where we'll have multiple annotated methods with cacheable, cache put, all the caching annotations that we feel is necessary for that method, right? So what happens is when the request comes from the controller, AOP proxy intercepts the call. It sees that the method has this annotation. That means I have to intercept this call. The method won't be executed. What it does instead is it'll intercept the call and send it to a proxy. And where it'll search for the cache first. If it sees that the cache has the data for this key, so it'll send the data of that key as the response. If not, then it'll come back to the method and then the method will be executed, right? So here, since we're talking about cache key generation, like we go in the concurrent hash map and then we look for a specific key, right? So this key we provide to that annotation. I'll give an example from code as well here. For example, if we come here, we have this cacheable annotation, right? We've given the parameters first of cache name, where the data will be stored, and the key. So this key by Spring Boot, we write it in a spell expression. It's a special expression language, which is basically written on behalf of whatever the parameter you want to send in the method. For example, you're asking for a data for ID, right? So we'll be keying it down with the ID only. So next time you request the same data with the same ID, it will know that this key belongs to this ID, right? So the key has been generated on the basis of ID only. So we'll retrieve the same ID data, right? So this is the spell expression that Spring Boot uses in order to make your keys. So before a method executes, as I just explained, that the proxy checks the cache to see if there is already a stored result for the generated key. If cache hit is there, for example, if you find that data in the cache, so so the actual method is not executed in that case, and the result will be returned to the controller and from there on to the client. So the database call will be bypassed in this case. And if it's a cache miss, we don't find the data in the cache, so we go and execute the method and then retrieve that data and store it in the cache as well. So in between, when we were talking about cache interceptor activation, the calls, whatever calls it gets diverted, it gets intercepted, right? So the purpose is to intercept method calls on beans that are annotated with caching annotations. Whenever we build an application, we give it the annotations. We give the annotation to the methods so that the Spring knows that this call has to be intercepted, right? So when a method call is intercepted, the caching interceptor examines the caching annotations present on the method. What annotation is present? Is it cacheable? Is it cache put? Is it cache evict? So based on that, it'll intercept the call. Key generation and cache lookup. It generates a cache key, again, that we talked about with the spell expressions, and conditional execution that we've been talking about. It's cacheable in, okay, so I'll just make a difference here of cacheable, cache put, and cache evict. So cache evict is basically the interceptor ensures the relevant cache entries are removed as specified. So what we're doing here is we're making a copy of our database here, right? So we need to maintain the integrity of our data. We need to maintain the consistency of data as well. So whenever the data gets deleted in the database, it should be updated in the cache memory as well. So when on the delete methods, we make sure that we apply cache evict. So whenever the data gets evicted from the method, it gets applied to the storage as well. And in cache put, what happens is the call never gets intercepted. It will always execute the method, and then then the next time the request comes, it will store the same data. It will get the same data from the cache memory. And in cacheable, the request always gets intercepted. It'll go and look in the cache memory first, and then if it doesn't find it, then the method gets executed. So these are the conditional execution. Now we have how the activation of the caching infrastructure works. This we've been running around these sentences only. So I'll just read it out. So when you annotate a configuration class with enable caching, it tells Spring Boot to start looking for caching annotations. These are the annotations. And how it works, Spring uses AOP to intercept calls to methods that are annotated for caching. And this interception allows Spring to check if a value is already stored in the cache and either return the cache value or execute the method and cache its result. Anything till here?
Ria, is this asynchronous proxy or a synchronous proxy? Like the proxy callback for cache lookup is asynchronous. It should be asynchronous, I guess. I just
Uh,
wondering.
can you elaborate?
Like the proxy gonna check the cache
Right.
while the method execution is held up. So it's gonna be checked parallelly, or it's gonna be checked, holding the execution of the function.
So it's synchronous only because we're not making threads here. So
Okay, okay.
it goes in synchronous fashion so that whenever you write the operation, it stores in the cache first, and then you can read the operation.
Okay. And do we have to specify the limit of the cache when the cache is being built up, or and what is the algorithm for holding up the size of the cache? For example, the oldest one gets like, I'm
Right.
just
So
forgetting.
for
There are some.
that,
Yeah.
right. Okay. So I'll just explain. I did not put it here. So for that, we can customize our cache by giving it the eviction policy. So we have various eviction policies as well as to when the data will be stored and when it will get evict from the cache. So we have LRU, we have FIFO.
Yeah. 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 That's right. Yeah.
These right. So
Okay.
these eviction policies helps us to maintain the size of our maintain the storage of our cache so that it never gets
Okay.
overloaded.
And is it a fixed size or a dynamic sized cache? Like,
So
if in case we are running out of the memory, with that particular process is going to shrink down its size and, expand it if in case the memory is available or something like that, or not.
okay, so is it in respect to the cache alone? Because when we're talking about in-memory cache, so it is taking the storage of our RAM only.
Yeah, that is right. That is right. But then, does it have a default size, which is like,
Okay, I cannot say about the
increasing
default.
and decreasing? Like
Oh,
it's
cannot right now comment on this. I'll have to explore about this and then I
okay.
can give
No
you the
issues.
data.
Yeah, no issues. Yeah.
Okay. So when we talk, okay, can I move ahead?
Yeah.
Anybody
Yeah.
else?
Yeah.
Okay, thank you, Indrajit. So now we have cache storage in Spring Boot. So when we're talking about cache, where is it getting stored? We did talk about the data structure that it is using in the backend, which is concurrent hash map. But what memory is it using? And if you're not providing it with a provider, what is it using? Right? So we did talk about that if the specific provider is not found, Spring Boot will automatically up the concurrent map cache manager, which will handle the rest of the caching, right? Otherwise, what we do is we give a configuration in our application properties with this Spring cache type. What is a cache type? So ahead, we're going to see that we'll be giving it Hazelcast. So if we don't provide, it'll go with the default one, right? So it is stored in the application JVM heap memory. The data, the main disadvantage that we have in our Spring Boot caching is that our data cannot be persistent. Every time you run your application, your data will be lost. No automatic eviction unless configured, right? So the data will sit there and hold your memory. If you want to evict your data, you have to configure it. And it has a limited heap memory again, right? So this was about Spring Boot default caching. Now we're going to move ahead to Hazelcast. Right, before that, I wanted to show you something about the cache manager only so that we have a better idea. Right. So this is the concurrent map cache manager that we were talking about, right? If we're not giving it any of the cache provider. Now we'll see when we configure Hazelcast in our class path and it reads that the Hazelcast beans are there, dependencies there. So it'll automatically get Hazelcast cache manager to handle rest of the caching for you. Okay. So now we're going to read a little bit about Hazelcast. So up till now, what we were doing is, sorry. So up till now, we had Spring Boot's default cache, which was using concurrent hash map, which was local to each application instance. For example, the developer is working on an application and the caching is also local to him or her, right? So it cannot be shared. So with Hazelcast, that is known to be in memory data grid solution, it will provide us with distributed caching capabilities and that will have distributed caches shared across multiple instances. If we have multiple application instances running, we can have distributed caches shared among each other. So it's not local anymore, right? So this will give us consistent cache state across our entire application cluster. So whenever a cache gets updated, every node will get to know. So this way we can reduce the data inconsistency, right? Now, moving ahead, we have, okay. So before this, I just wanted to talk about like what Hazelcast is getting us on table above Spring default caching that we've read. So it gives us scalability. Now that we have distributed system here, we have multiple nodes, multiple clusters running on different machines. So we can scale also horizontally, like we just discussed about the memory disadvantage there, in memory disadvantage there. So now if we need more memory, we can scale our clusters horizontally and add more nodes to it. So with this, Hazelcast will provide like much larger cache sizes distributed across many machines, right? So again, now second one will be failover mechanism. We have a backup here. We have a fallback option here. So Spring caching had no built-in failure. We were not even able to make our data persistent. Every time our application runs, the data will be lost, right? But with Hazelcast, it'll provide us with more, with automatic failover, with backup partitions. So if one node fails, we have another node holding the same data with the backup data, right? So cache data will be preserved over other nodes if one application instance fails. So here in the diagram,
Sorry to stop you, Ria. I didn't get that replication part. Can you please repeat that, please? I'm sorry.
which
Like
part?
one node's data is getting replicated to other node. Can you just
Correct, correct, correct.
explain again that?
So what happens is when we are saving our data, the data is getting partitioned over the nodes, right? So if our data is getting stored in node 1, for example, right? We cannot only rely on one node, right? If it goes, the data will go. So we have the replication of our data in other nodes as well. So we have backup partitions for this.
Okay, all right.
Yeah. So for this diagram, whenever a request comes, the Hazelcast client, what it'll do is it'll retrieve the full member list and establishes a connection to all the nodes, right? So we have different nodes, we have different members. Whenever you'll up the instance of your application, it'll, one instance of your application will make one member in one node. Okay, so we have Hazelcast client in play, which will hold all the data of all the members and the partition of your data, like which partition is sitting in which node. So whenever the request comes from the user, the Hazelcast client knows which partition to aim for, which node to aim for. Okay, and it'll also hold the data of the current partition table, like which data is where. So whenever if the node fails, it'll get to know. It's all happening in live. Next up, we have data partitioning in Hazelcast cluster, like how the data partitioning comes into play. So whenever you have your data, it'll get partitioned. It cannot always be stored in one chunk. So it'll be partitioned, and by default, Hazelcast provides 271 partitions per cluster. And partition distribution, each partition is assigned to a node in the cluster. How we saw here, this is a cluster in which we have multiple nodes. Backup partitions for fault tolerance, for a fallback option. If one node fails, we have a copy of that partition in another node as well, which Hazelcast client has the idea about, has the information about, right? And then we have consistent hashing as well. Whenever we store our data, it'll be stored via keys, and that keys are found by what? By the hashing algorithm. So when data is stored in Hazelcast, the key determines which partition it belongs to. So by the key, it knows which partition it belongs to, which node it belongs to, and therefore which node owns that data. So we have Hazelcast topologies, how we can integrate Hazelcast in a Spring Boot. So one is by embedded, second is client server. So in embedded, what happens is that no separate cache is required. You have one cache server, and then you have your application. It is all in one. Your one application instance will be your one member of the cache. So now, since it is all belonging to one JVM only, so the data access will be faster, right? But what happens in client server is everything is standalone body. Everything is standalone entity. Your Hazelcast client is one, then your application is there, and then your clusters are there. So Hazelcast client sits in between your application and your clusters. So it will have the information of all the partitions that are coming in play and the clusters which are going down, which are being up, which are being added, right? So it'll hold the information of all the clusters, and it can. So what happens here is everything can scale independently also. Everything is not dependent, but in embedded, everything is dependent. Whenever you up your instance, whenever you up your application instance, one member will be added in the cache cluster. But in client server, whenever you have to scale your application, it would not be hindering your Hazelcast clusters, right? So here are the advantages and disadvantages of, and all this depends on your use cases of your applications, your organizations, how you want to cache your data. So based on that, you can integrate your Hazelcast in your Spring Boot application. So I've covered all these points more or less. Moving ahead. So we have the concept of near cache here. So what happens is with near cache, if I explain in simple terms, it's like cache in cache. So whenever the request comes from the user, it goes to the Hazelcast client and then to the cluster, right? So what happens is before going to the cluster and finding in which node or which partition the data would be sitting. And so what we do is we have near cache, which is a local in-memory cache, which is with Hazelcast client only. So whenever the request comes, it will go to near cache first, and Hazelcast client will look if the data is present in the near cache, then it'll send that response accordingly. If not, then it goes to the Hazelcast cluster and look for the partition. So this is one of the advantage that Hazelcast has given to us. Okay, so we have caching data on the client side, which I just explained that we have a near cache, which is a local cache that is created on the client side. Client here, we're talking about Hazelcast client and not the user. So when an application wants to read the data, first it'll look for the data in the near cache. If the near cache doesn't have the data, the application requests it from the cache cluster and will add it to the near cache for future request. So now one advantage that Hazelcast has explicitly provided to us is, okay, I'll just explain the problem statement here first and then the solution of why we do caching of web sessions as well. So we have multiple servers, right? And whenever a session will be stored, it'll be per server. So a server will have its own session storage. Every server will have its own server storage. So what happens is whenever a server goes down, if it crashes, so the session storage will be lost. And with the help of the load balancer, if it sends a request to some other server, then again we'll have to create the session storage because the previous session storage is lost. If I give you an example of an e-commerce, for example, a user has logged into an application. If the session is lost, he'll be logged out, right? The information will be lost. So this will result in data loss. So what Hazelcast has provided us to fix this lost session storage, we use web session clustering. We also call it session replication, where session data is stored in a shared distributed cache in Hazelcast. So Hazelcast will act as a centralized session. So it has a centralized session where all the servers will store its session. So any of the server goes down, the other server can access that session stored data from there, right? Okay, so that was about the architecture of Hazelcast. So now if we move on here, I kept the code very simple. So we read about the annotations, the enable caching annotation, and then we have on service layer cacheable, cacheport, right? So it will work like how I explained. This is the update employee method where we're updating the data, we're writing the data. So on every write operation that we do, we have to put this annotation, cacheport. And on the read operation methods, we usually use cacheable annotation, right? For Hazelcast, I've set up this Hazelcast Management Center where this UI has been provided to us by Hazelcast. So the steps, if somebody needs, I can send this to them, right? So by this, we can monitor what clusters are up, how many partitions are there, when the data came to us. Okay. So for example, right now I have 2 members up. I ran my application. So to set up Hazelcast, you don't need anything. You just need to add the dependency of Hazelcast, and then you need to add configurations. If you don't add the configuration of your Hazelcast instance, so what Spring Boot does is it'll pick up the default Hazelcast configuration that we saw in Hazelcast manager, cache manager, right? To make the custom configuration of your instance, we add the configuration and then we set up the Hazelcast cache manager as well, right? So what I've done till now is I just wanted to show you how different members works. Like whenever an instance goes up, it gets added to its member list, to the cluster member list, right? So for example, I have 2 members running here. This was the second one. I can start running the third one. If I okay. Right? So till now I had 2 members running because I had 2 instances of my application running. Now when this is just giving a gist that this is the embedded Hazelcast that we're running right now. Okay, so when I up my third instance of the application, it'll add 1 more member to it. Now we can come here and we can monitor that we have 3 instances running for one single application. Okay. Right. So Indrajit, your doubt about the eviction, like how we evict. So here we've set up this eviction policy, which is least recently used, LIU,
Okay.
right, to
Mm.
keep evicting the data. Okay.
Okay. It's a dynamic one based on the, yeah,
Right,
that's great.
right. So,
I have
and
a question. I
uh-huh,
have one question, Riya. Um, this is the embedded one. In the embedded one, this the embedded one where we may have
right,
cluster with multiple
right.
nodes, or okay, in both the in client server and embedded both will be having the same topology. You mean to say where we have a
Right.
cluster with multiple nodes and you know partition and replication happens. Okay, all right.
Okay. So this was it from me. I've not explained in detail about like how this will work because uh, it would have taken a lot of time. But if anybody wants how to set up and like what are the steps to set up these, to integrate these into the Spring Boot application, I can share them personally.
It's very well done, Riya. Thank you. And Ria, I have a question whether this
Mhm.
cacheable can also be done on top of request, get request, and these kind of annotations where we are creating
Great.
APIs. Should be, right?
So, right. So on all the methods which are doing your read operations, so what we're achieving here, we're just copying the data from the database, right? So whenever you have to read the data, whenever the user requests the data that he or she wants to see, right? So these are all read operations. So we can apply cacheable annotation to all the read operation methods.
Yeah, perfect. Yeah. Yep.
Yeah. So that was it about the session. Anybody else has doubts?
Okay, thank you, Ria. A very well session that you had delivered. And thank you, Indrajit, for making it very engaging. I mean, keeping you kept asking questions. So thank
Yeah,
you for that.
thank you. Thanks a lot for being so communicative during the session.
Yeah, thank you, Ria, for the session. It was really informative.
Thank you.
Great.
Also,
Fine then. Yeah, please go ahead, Ria.
no, I was just saying that if anybody else has doubts and if they read about it, if anything else comes up, you can ping me personally.
Yeah, sure. There you go. Ria is available for any doubts that you have regarding the session. Fine then. Thank you so much, everyone, for joining in. Let's meet for the next session. Thank you, everyone. Thank you, Ria, again for an amazing session that you had taken.
Thank you.